Thing to say.
Yes. Okay, so as we start into lesson 1.2, and really what I should have titled this is lesson 1.2, part 2, because that's really what it is. Okay, this is lesson 1.2, part 2, and I probably should have just done that from the get-go, but I'm doing this bit by bit, and okay. Now, one thing that I left up here, the page of transformations. List of transformations. Did those change? No. Not a single thing changed here, guys. I left this exactly in place and then changed the rest of the document. Okay? But part 1 was absolute value functions, which have what shape? Absolute value is the V, right? It has that pointy vertex. Okay, so today we are working with quadratic functions. So we're still in the same lesson. We're still doing some of the same stuff, but we're talking quadratics. So we're going to jump down here, because I don't need to spend time talking about this, do I?
Nope.
Okay. We're going to jump down here to quadratics, and our parent function is y equals x squared. So everything we do today is based off of y equals x squared. Now, do we know what y equals x squared looks like? Okay. It's a u. Officially, there's a name for it.
Parabola.
It's a parabola. Yes. Okay, so I'm going to go ahead and write that word down because I don't know if I ever put that word in the notes today. And I will say, we have a whole chapter coming up later that is about quadratics. But you're getting some introduction right now. Okay? And we'll just review later what we need to. Now, specifically, where does my u go? And this is where we're going to do an XY chart, right? To get us started this time. What X values should we use?
0.
0 is always good. I like 1 too. And then we're going to talk about some negatives. Okay, so I have -2, -1, 0, 1, 2 on there. What does x squared mean? We take -2 and we square it, yes? -2 squared is 4 because it's -2 times -2, which is +4. Now, if you do that on a calculator, if you try and square a negative on a calculator without putting the parentheses, it's going to give you a negative instead of the positive. So beware. Okay, like on these the calculator I use, if I type in -2 squared, it's going to give me -4 because it's just doing the negative of 2 times 2. If I really want to square the negative value, I need to put parentheses around it. Okay, so good learning tool there. What is -1 squared? -1 times -1? 1. 0 squared? 0. 1 squared? 1. 2 squared?
4.
4. Okay. Now, one way I teach this is that you really, as long as you know this section down here, as long as you know, like this is what I always try and have students memorize. 0, 0, 1, 1, 2, 4. That's a basic parabola there, right? 0, 0 representing the vertex. The next set of points go over 1, up 1. And the next set of points go over 2, up 4. You can kind of memorize that basic parabola. And it's really easy to then move it around and stuff. So if I graph this, 0, 0, 1, 1, so right 1, up 1, 2, 4, right 2, up 4. Right there is the right side of my parabola. What can you do for the left side if you want? Can you reflect it? Yes, you can. Parabolas have that symmetric function. So we also need to go left 1, up 1, left 2, up 4. Now, it's kind of hard for me. You have to be careful. Is this a V?
Nope.
No, it is a U. So try not to make a pointy vertex. I can slip up and be just as guilty as you guys. That's not pointy, but you're not making a pointy vertex. It is a curved vertex, correct?
Yep.
Okay. Little vocabulary. What is the vertex on this basic parabola? 0, 0. Thoughts on the axis of symmetry? Ah. Does this work the same way with what we were doing the other day?
Yep.
It does. Okay, axis of symmetry works the same way it does the other day. Yes, some of you may be saying, oh, the axis of symmetry is the y-axis. I agree. I'm not arguing. But on homework, they're going to want the equation, aren't they? Okay. So axis of symmetry is always x equals a number. The number is always the first number from the vertex. That rule still applies. Makes life easy today, doesn't it? Okay, questions at this. You got the basics. As I said, my suggestion is that you pretty much memorize this right here, the 0, 0, 1, 1, 2, 4, because then you can graph the right half of the parabola and you can reflect for the left half. Okay, first set of examples. Looks kind of similar, if you will, to our last set of notes. I just changed the examples out. Graph each function, identify transformations, vertex, and axis of symmetry. Y equals x minus 4 squared plus 3. Thoughts on what's going on with this graph? You have that chart up top of your notes, yes? Same chart as the last set of notes. What is that minus 4 in the parentheses doing?
Translating the function right.
Okay. The options are in the parentheses left or right, and I always say left or right, opposite the sign. You hear me say that enough, it'll get ingrained in your head, I hope. So, in this case, the minus 4 is going to take us right 4. What about that plus 3? Okay. Number at the end is up or down. This time it's the normal direction, the direction you would guess. So a plus 3, we're going to say up 3. Okay. So I teach this the same way I taught the absolute value. We're going to take the vertex and move it right 4, up 3, and then we're going to regraph that same parabola shape. You ready? Mm-hmm. So I'm going to go right 4, up 3. That's my new vertex, correct? Mm-hmm. Okay. If you use that whole idea of 0, 0, 1, 1, 2, 4, 0, 0 represents a vertex, yes? 1, 1 says our first set of points go over 1, up 1 from the vertex. So you can go over 1, up 1 to the right, and over 1, up 1 to the left. 2, 4 says our second set of points from the vertex go over 2, up 4. So go back to the vertex, and we're going to go over 2, up 4. And the same thing the other way. Over 2, up 4. And so this is where that's where you'll see me keep coming back to that whole idea of 0, 0, 1, 1, 2, 4. That's in relation to the vertex, right? And we can connect our points. Now, When I was looking at the homework, I can't remember if this example made it in the final assignment or not. I feel like there was some place that they said also graph the axis of symmetry. How would I graph the axis of symmetry? What represents the axis of symmetry? That's just the idea of a dotted line through the middle. So, I can't remember. You might have to graph the axis of symmetry on an example or two. If you do that, it just means putting a vertical line that goes through the vertex. They'll probably want it to be dotted because traditionally we do an axis of symmetry as a dotted line, a dashed line. I can't remember how homework goes on this, but does that give you some information at least?
Yep.
Okay, let's write all this stuff down. With this graph, we translated, using that vocabulary word again, right 4 and up 3 units. If we went right 4 and up 3, what is my new vertex?
4, 3.
4, 3. What about axis of symmetry? Not just 4 though? X equals 4. I'm trying to get it so when we have a quiz or a test, you guys don't get caught and get that wrong. X equals 4, not just 4. Questions on that one? Okay. Y equals x minus 1 squared minus 5. Where is the parabola going? I heard right. Minus 1 in the parentheses is left or right, opposite the sign. So right 1.
Down 5. Down 5.
Minus 5 at the end is up or down with the direction of the sign. So down 5. You know, I realized as I said it, I called this a parabola. How do I know this is going to be a parabola?
Where?
The little squared there, yes? If you have an x squared as your highest power, that's what's telling me it's going to be a parabola. Okay, so right 1, down 5. Can I just draw any old random U? Not if you want to make me happy. Okay, not if you want to get the full points on the quiz or test, right? So, where's my first set of points go from the vertex?
1 over 1.
Okay. Over 1, up 1. Where's the next set of points go?
Over 2, up 4.
Over 2, up 4, because this is a x squared. Wait a minute. I did, didn't I? Pros, cons of the bid queue. Sometimes it's hard to because I'm at an angle and I'm not directly, it's centered in front of it usually when I'm writing. It's sometimes hard to know. Okay. Your parabola looks something like mine, I hope.
Yep.
If we had to draw in the axis of symmetry, where would we put it?
Down the middle.
Yeah, down the middle, right?
Yep.
And again, I don't remember if you have to draw it in or not. So, okay, let's see. What were my transformations? We took this graph and we translated right 1 and down 5 units. Since we went right 1, down 5, where does that put my vertex? 1, -5?
Yep.
If my vertex is 1, -5, where did I draw this axis of symmetry at? I drew it right here through x equals 1, didn't I? Okay. Are we good on this part?
Yeah.
Okay. Back of the page, we get to look at when there's, well, on this part I'm focusing on a fraction out front. Okay. And so we're looking at our vertical compressions basically. Okay. When we look at y equals 1/3 x squared, officially, what is my transformation there? What is this 1/3 going to officially do? Vertically compress. Because if you're multiplying by a number less than 1, and 1/3 is less than 1, right? Then it's going to shrink it down. Let's see. I think I'm going to go ahead and write that in so I don't forget. Vertical compression by factor of 1/3. Now, where's my vertex? Why maybe 0, 0?
There's no other translation.
Okay, yeah. There's no translations, are there? There's nothing telling me left or right. There's nothing telling me up or down. So if there's nothing telling me left or right or up or down, where are we going to expect that vertex to be? 0, 0. Now, can I just use the 1, 1, and 2, 4 to get my other points?
Nope.
No, because we have that compression. This parabola, instead of being taller and skinnier, is going to be wide. It's going to squish down, so it's going to be wider. The best suggestion I have when there's a fraction out front is that you do an XY chart. I don't have a good shortcut for you. Okay? So I'm going to suggest we do an XY chart. Now, if you want to put your 0 in technically, we can put 0 in. But when you put 0 in, it's going to be 0, 0, and that's going to be your vertex. Now, depending on what kind of mood you're in, depending on what kind of math student you are, do you want to use 1 as your next number? Some people are going to say sure, they'll make it work. Other people are going to say, ooh, because what happens when I put 1 in?
Yeah, a fraction.
You're going to have a fraction, aren't you? Because when we're plugging this in, this would be 1/3 times 1 squared. Realize that's how we're plugging in. Well, 1 squared is 1, 1/3 times 1, 1/3. You want to have to graph the point 1, 1/3. Here's this. Do you want to have to graph it on your digital homework?
No.
No, it's hard enough to get whole numbers there, isn't it? More or less have to deal with fractions. Okay, so, I'm not saying you can't use 1. It's just not pretty to graph. What's a whole number I can use that's going to help make that fraction go poof and disappear? Why 3?
Because
It makes 3/3.
I usually try and say, and there's other things you can do too. Multiples, if you have a fraction, multiples of your denominator. So 3 is a multiple of itself. What's another multiple of 3? 9. There's one before it though. 6. So I'm actually going to suggest we use 3 and 6. You can use 9. It's not wrong, but 6 is already getting a little big, so 9 gets a lot bigger. Okay, so I'm going to do a little bit of scratch work off to the side here for those that might need it. 1/3 times 3 squared. What is 3 squared? 9. So then we're doing 1/3 of 9. Some of you can use the logic, and 1/3 of 9 is 3. You can multiply across and get 9 divided by 3, which is 3. So we're going to have 3 as a point. And I'm going to use 6. Some of you are saying, Mrs. Sargent, you're really working these out? Yes, I am, because some of you are going to get confused if I don't. So, and if no one's getting confused, well, you just get extra work from me. 1/3 times 6 squared. Remember, Aunt Sally wants you to do your exponents first, yes? We all know Aunt Sally? No, because you guys use PEMDAS.
Yeah.
That's who you guys know as PEMDAS, right? Exponents come before multiplying. Sorry, I'm old school. I say please excuse my dear Aunt Sally. You guys are looking at me like I'm crazy, so. Okay, 6 squared is
36.
36. If you're doing 1/3 of 36, multiply across, it's 36 divided by 3, which is 12. That's why I didn't really want to use 9, because that's going to even give me a bigger result. Okay, let's graph this. Already got 0, 0, 3, 3. Right 3, up 3. 6, 12. Right 6. Up 12. Which I believe these are 10 by 10 graphs, if I'm not mistaken.
Yeah.
I have no problem with, if you're doing something on paper for me, you only have to count 2 spots off the graph, yes? I'm fine with that. Okay, I kind of put a dot to kind of represent the missing one, and, I'm fine with that. Now, a little bit harder if you're going bigger off the graph, but am I done with this graph?
Oh, you gotta do the other side.
Yeah, we gotta do the other side of the parabola, yes? And I didn't do an XY chart for the other side, because it's a parabola, it's symmetric. So now I need to go left 3, up 3, and left 6, up 12. Now, as I draw this parabola, did it get wider? That's the idea. It gets wider because we compressed it. Now, here's the trick. What you have to watch out and not do. What is 1/3? 1/3 is not slope. You can't think slope with a parabola. Okay, at least not when it's a fraction like that. With the absolute value, I know, I let you get away with that trick. That's fine. Doesn't work here. Okay, when you're ready, thoughts on the second example?
We try to do it by ourselves.
What'd you say?
No. I was gonna ask if we can do it by ourselves.
You can to an extent, but my only thing is I want to make sure that I get through all the notes. So that's why I make sure we keep us moving. What's different about this one?
Negative.
There's a negative, which means it's going to reflect. Okay. And what's the 3/4 do? Three-fourths does the vertical compression. So this one is going to be still vertical compression. By a factor of this time 3/4, but then it's also going to be reflect. When the negative is out front, we are reflecting across the x-axis. Are you thinking about what x values you want to use? Okay. We still like 0, don't we? I don't even know if you officially have to put it on here. We still like 0 because 0 is still going to be my vertex. It's an x squared. There's no plus or minus in the problem, like adding or subtracting. That's my vertex. Okay, thoughts on numbers to use as x's other than 0? 2. Would 2 work?
3.
No. It has to be.
I'm going to veto 3 because 3 is not in the denominator. I need my denominator to cancel out. 4? Will 4 work?
Yeah.
4 definitely works, yes. Because what did I suggest over here? I suggested multiples of the denominator, yes? So multiples of 3. 3, 6, 9, 12, whatever. This time I'm going to suggest multiples of 4. Now, Josh threw out 2. I'll be honest, I like 2. Because it's not going to give me huge numbers when I graph it. And why does 2 work? Because when I square 2, 2 squared is going to become 4, and my 4's will cancel. So it works in this case. If you don't like 2, then don't use it. If you 2, 4, technically 6 would work. I mean, 8, and see, here's the problem with 8. You're starting to get pretty big, aren't you? So it doesn't have to be these exact numbers, but you want to find numbers that are going to end up canceling with the 4. That's what you want to find. So I would do 2 and 4 when you have this. That's what's going to be easiest. Not saying the others would be wrong. So, okay. Negative 3/4 times 2 squared. What is 2 squared?
4.
4. Negative 3 over 4 times 4. 4 as a fraction is 4 over 1. The 4's will cancel. What remains?
3.
A whole bunch of 1's and a negative 3. Negative 3/4 times 4 squared. What's 4 squared? 16. I'm going to go down here. Negative 3/4 times 16. 16 as a fraction is 16 over 1. Some people would just multiply across. I'm old school. I like to cross cancel. What do you know about 4 and 16? They both divide by 4. 2 also, but I'm going to go big. 4 divided by 4 is 1. 16 divided by 4? 4. Negative 3 times 4 is negative 12. Does it make sense these numbers are negatives? Yes, because we're reflecting. So, 0, 0. Write 2 down 3. Write 4 down 12. That's the right half of the parabola. And you can do the same thing on the other side. We went right 2 down 3. I'm also going to go left 2 down 3. And left 4 down 12. Golly gee. Okay, those are the harder ones of the lesson, right?
Yeah.
Again, when you see a fraction out in front of x squared, don't think slope. Okay? Besides the fact a parabola has a curve to it. It's not a constant slope. Now, I have 2 more examples down at the bottom, right? And in the previous lesson, part of the lesson, we had, what was this? General form of an absolute value equation. Here we have vertex form of the quadratic equation. You'll notice it's similar, except instead of absolute value, there is a squared. Okay? H and K is still my vertex. A is still my stretch or compression. Now, we're going to go down to the bottom. And we are going to try and take these graphs and write equations for them. Okay? So the directions say determine the quadratic function of the form y equals a times x minus h squared plus k, whose graph is given. So when we write our equation for this first example, we're going for this form right here. What can you observe about this parabola right here?
Stretch or compress.
Ooh, you're a step ahead of me. Okay, I'm going to come back to that thought. She says it's not stretched or compressed, which is a very important thing to point out. I'm going to come back to that thought. Where's our vertex here? Can you pinpoint the vertex? Okay. -1, -4. Where is my vertex in my formula? What letters does my vertex represent?
H and K.
H and K. So right there, I know I'm going to fill in -1 here and -4 here. Now, okay, the A is the hard part. Sometimes, at least. You have to stop and think. Because A is your stretch or compression. What does a typical parabola do? The general parabola does what? It goes over 1, up 1. Oh, does that match up?
Yeah.
It goes over 2, up 4. Oh, are those points matching up?
Yes.
Okay, so what value do I use for A if there is no stretch or compression? It's just the regular everyday parabola?
What?
1. Okay? 1 means it's just a regular everyday parabola. No stretch, no compression. Okay, you have the information to fill in this equation now. So, my equation's going to start y equals. Could you put the 1 in place of a out front? You can. Or the other option is you can just leave that off. So, like, for right now, I'll rewrite it here in a moment. I'll put the 1 there for a moment. And then in the parentheses, it's x minus h. What's h? Negative 1 officially, right? So x minus negative 1 squared. And then, I'm kind of writing it funky. It's plus negative 4. I would clean that up, though. I wouldn't leave it like that. And I don't, if Savas is anything like Math Excel, they wouldn't count that. I mean, it's equivalent, but they wouldn't count it. And so the nice, neat form would be y equals, you don't have to write a 1. So x, we know minus a negative is plus 1 squared. What about plus negative 4? The best way to write that is minus 4. That's the answer that, if Savas is a lot like Math Excel, that's the answer they'll be looking for. I don't even know if they'll let you put a 1 out front for the a value. I don't know. It's not necessary, so. Okay? Okay, let's look at our last example here as I looked at the time. Shouldn't have looked at the time. So again, we're filling in y equals a times x minus h squared plus k. So, what can you tell me here?
Your vertex is negative 2, 5.
Okay. Vertex is negative 2, 5, and of course those are my h and k. So can you fill those into your equation?
Yeah.
Negative 2 for h and 5 for k. Okay. Now, for a, is there some kind of stretch or compression this time?
Yes.
Yes, because I can't just go over 1 and then, in this case, down 1. I have to go,
Down.
I think it's down 3, isn't it?
Yeah.
Before I actually hit a cross point. Now, when you're going over 1 and then up or down 3, something like that, a whole number, this is, you can actually, first of all, this is going to be a stretch, right? It's making it taller, skinnier. It went farther than 1. You can actually use the idea of slope here in that because we went over 1 and down 3, if you think rise over run, that is a 3 over 1. And so we are going to have an a value of 3. Okay? So if it had gone, and that's just if that's what it is to get to, if it's over 1 and say 2 to get to your first point, then a is 2. If it's 3 to get to your first point, a is 3. However many. Obviously, if it's less than 1, those are the fractions. Now, what's the other thing we have to take into consideration?
Going down.
It's going down. What's that mean about my equation?
Negative A.
We're going to have a negative a value. So whether you put it here or whatever, so we're going to have y equals negative 3. What about x minus negative 2? X plus 2, quantity squared, plus 5. Okay? Your homework is in Savas, as you expect, right? This time, it's going to say lesson 1.2 again, but this time it's going to say quadratics. And it is due when?
Tomorrow.
Tomorrow. I think it's like right around 10 questions. Give or take one. Okay, 10 questions. I tried to keep it reasonable. Let me know if you run into problems.